this is going to be for the laminar flow for this part of the project. So I'm going to be showing you how I did this. So first, what I did was I copied the envisaged flow geometry and mesh. So I will go into the mesh part to show you that. So what I did here was first I created the mesh. We did a triangle method like we did in the previous video with the envisaged flow. So we did the triangle method. We selected the face and then we selected triangles and then we did edge sizing for mesh and we selected on the circle. And then we just changed it to a number of divisions and 200 divisions and then we changed the behavior to hard. And then for the inflation part, we selected on the face. And then we selected geometry selection and the boundary is the circle in the middle. And then we're going to change inflation option to first layer thickness. And then first layer height is going to be 3e to the negative 3 meters. And then we changed it to 100 layers and 1.2 growth rate, which is already selected for you. It should be 1.2 for the growth rate. And then name selections, we just clicked edge sizing up here. So this, and then we clicked on the edge and we right clicked, and then we changed the name to velocity inlet for this side, pressure outlet for this side, and then we're gonna copy, or not copy, but we're going to click control, and then we're gonna select these two sides. That's gonna be our symmetry. And then after we generate, and then the mesh should look like this after we're done. And then to get that, we went to element size for the mesh and just changed it. And I ended up changing it to 0.12 meters to get it to look like this. And then our statistics, it should be 342,814 is what I got. You don't want to go over 500,000 because that's our critical Reynolds number. So then after we do that, I went into the setup portion, and for the setup portion, I went into models, and then I right clicked and then I changed the model to laminar. And then we go into our materials and we click on air. And then for air, I just changed the density to 1 and then the viscosity to 0.05. Then we're going to press change and create and then close. And then just to make sure that the fluid is still selected as air, we're going to go into surface body fluid and it should say right here, it should be air. And then for our boundary conditions, we're going to go into our reference values and just make sure everything is still lined up for what we selected it from, and we want to compute from the velocity inlet. And then we went to report files. You don't have to do this part, but I did just to like print it out at the end. So we went into report files and then we created a report. Let me do it this way. So you press new and then you go and press OK. And then on the top, it should say pressure coefficient. And then it should also say, I'm pretty sure it says pressure coefficient. And then after that, we're going to go to initialization, press on initialization, more settings. We're going to change our iterations to 25, apply, cancel. And then we're going to run our calculation. And then we're going to change the number of iterations to 1,000 and then calculate. And then when you're done, it should pop up the two reports. So I apologize. This is your drag coefficient. And then this should be your just drag force. And then this is what the scale residual should look like for the number of iterations. And then I also did a pressure contour, but it looks kind of weird on here, so I'm just going to do it in the results section. So I'm going to get rid of this. So then that's what I did for the setup portion. And then we're going to go into solution, or I apologize, that was the solution. I'm pretty sure. So we're going to go into results. So for results, I went up here and I did contour. And then, 1 second. So we're going to go into contour. And then I went down here. And this is should be a pressure contour. Or I guess it's a velocity contour. So I went to all domains or symmetry 2, which is our top and bottom. And then I went to velocity U, and then that should just stay at global. And then number of contours, I did 1,000. And then this is what I get for my pressure contour or my velocity contour. And then for our other contour, it should be pressure contour. And this is what my pressure contour looks like. So for pressure contour, I just went into symmetry 2. Wait, I apologize. I went to symmetry 2, then I did pressure and global, and then you can do 1,000 contours. It was just automatically set for me at 11, so I just added 2 zeros and made it 1,100. And then apply. And then to zoom in, you just go up here and then you make a box around it. And this is how you zoom out. So this is what my pressure contour looks like around my cylinder. Um, Actually, let me snip this quick. Then I'll show you how I'm going to do my other contour or my streamline. So for my streamline, I went up here and I click streamline, and then you go down here and then you start from your velocity inlet. So you click velocity inlet, you want it to be equally spaced, and then 1,000, and then your variable, I'm pretty sure it's velocity. So and then I did 1,000 points. Okay, so this is what it looks like, my velocity streamline. Um, and that's pretty much it. And then for my Reynolds number, I just calculated it in a formula, and same with my drag coefficient, but it's also in the report that I created for the when we went into our solution. So that's pretty much it for the laminar flow. And then just put your results in your document when you're done.